Okay, there's the view. Okay, got it. Perfect. Okay, hello, ladies and gentlemen. Welcome once again. We are here at Learn Math with me, Brian Sapinski, and we've officially fully made it into April now. April 7th, 2020. It is a Tuesday, 2 p.m. on the East Coast. We are ready to roll with some math stuff or whatever. And this is the live stream after WrestleMania. Not that that means anything because I don't have much of a live crowd either. And if you're chanting anything, I can't hear you. So, so I don't even know why I said that. I'm just messing around. Okay, so good to have you here. Now, before we get started with this, I'm trying to think. My wife Andrea, who you've seen on the show before and in some of the other things, her parents found this buried somewhere. I don't know what the heck this is. It came in this little pocket case or whatever. I'm gonna have to sit down and explore with this because I genuinely don't know what it is, but it is something math based. It's called arithma. I don't know. You look at this thing. Has anybody seen anything like this before? Does anybody know exactly what the heck that's supposed to be? Because I sure don't. Because you see, like the numbers in there, like said for addition, subtraction, like that. I see the digits, the zeros in between or whatever, and I don't know what the like. There's a thing here, something like that, but it's like nothing moves on the inside, so I don't know what that's supposed to be. And then I don't know what this latch is for because nothing slides out. I'm gonna have to see like, does anything actually maneuver on this thing? I'll have to take a look at it. If I do, I'll make sure to put this up in a video sometime later. But yeah, again, just so you can see it, they're like I said, the arithma. It's called definitely an old school thing. I'm thinking back to like the old school slide rules and stuff like that, and even those were before my time. So, who's to say? I'll have to pick at that later just to see what the heck is going on with that or whatever. Okay. In the meantime, okay, I'll I'll buzz Brianna and let her know that she's otherwise late for the show, or whatever the case is. But while I'm doing that, I know one of my friends who I hope is watching and tuning in right now, Paul Williams. He he had something that he literally just posted on his own Facebook last night, or whatever the case is. That I know he had some questions about, and he was looking to like revisit like some Regency tests or whatever the case is for whatever purpose. He didn't exactly tell me. So let me get Brian up here. Okay, but I figure I'll just make a mention of it here. It's something going into the algebra category in general, just so everybody has an idea. The premise of the type of problem that he was looking at had to do with, where's that doggone thing? Where is the factoring? Hang on a second. If you give me a second, because I need to sort this out.
Is 3 p.m. Pacific? Wait, no. Is 12 p.m. Pacific time 3 o'clock?
3 p.m. us, yes.
Okay, I just wanted to make sure because
I remember. What are you building up for?
No, it's because I remember like that like the first that like there's another event that was at 12 p.m. Pacific time, and I just wanted to make sure I got it right.
Wait. First of all, what other event? What am I missing here?
No, one of my favorite YouTubers is doing a stream, and she said a live stream, and she said it was at 12 p.m. Pacific.
Gee, thanks. I'm kidding with you.
Just coincidentally, it was today.
I'm messing with you. They'll just don't get over.
And it's like whatever.
Well, you could. No. I know what you're saying. I'm just, like I said, I'm teasing. So, okay. All right. So I'm just trying to find an example of what it is that I want. Okay, and I think I found it. Okay. So let's suppose that we had something that looks like this. Okay, let's say. All right. So my friend Paul was looking at problems that looked something like this. I'm just trying to make this up as we go there. He was looking into stuff related to polynomials and the like that. So I'm just checking to make sure that I've got it all in position right there. So kind of looking like this. So the premise of this type of problem is that he is, okay, all right, we'll be with you in a sec, Jethro. Okay, let me just get this one out of the way, okay, because like I said, I have a friend who was asking about this or whatever. So you hang tight, we'll be right with you in just a second, and glad you're joining us. Okay, so taking a look at this, Brianna, real quick. Okay, so the idea that my friend Paul was looking at with this polynomial sentence, because you can see we got several variables here and stuff like that, and the object is that he's trying to factor this sentence. Okay, now when we factor this, now you've done stuff with greatest common factor before, right? All right, so here's what I want. These four terms, as you see them here, they're ultimately going to get broken down into two sets of two. Okay, you'll see in a minute how it is that it's all going to end up. Here's the basics of what you want to see. I want you to focus first on the first two terms. I'm going to take these two and go split them right down the middle like so. Okay, so I want you to take a look at these two terms here. I want you to start with the 9 and the 45. Find me the GCF of the 9 and the 45. What could I divide them both by?
9.
Okay, I can divide them both by 9. Okay, so we get that. Now, in addition to the 9, do you see something else that they both have?
If you like add them up, they both.
No, wait. As you look at both terms, what's something else they both have? Just as you read them, what do you see?
F at the end?
Yeah, they both have an F. Okay. This one, remember, I think we talked about exponents. An F squared means you have two F's in multiplication. This just means you have a single F. So how many can I borrow equally from both of them? Yeah, you're right. Yeah, I could borrow one. Okay, so that means I could take those down. I can take from those down as well. So 9F would be the GCF of those two terms. Now, let's see what's left over from both of those when I do that. Okay, if you divide 9 by 9, you have 1. Okay, which I'm not going to write the 1 because the 1 is sort of, well, you'll see why in a minute why I'm not going to write the 1. And if you take away one of the F's, you have
2.
No, if you take away one of the F's, remember, F squared means that you have a product of two F factors.
Have one F.
You still have one F left over. So I'm going to put that F right there. That's what's left over there. Okay, minus. Now, 45 divided by 9?
5.
5, okay. And if you take away an F from this, are there any F's left? If you take away an F from this, are there any F's left? No. So it's just a 5 like that. Okay, so you've taken the first two terms, you factor out the GCF, and you saw what was left over. Now, we're going to do the exact same thing to these two terms over here, okay? And when we do, watch what happens. First, let's see. Okay, what could I divide both of these by? What GCF do they have?
7.
Okay, they both divide by 7, okay? Now watch what happens when you divide them both by 7. If you divide 7F by 7, what's left over?
1.
Well, 1 and the what?
And F.
And the F, okay. And then minus, and if you divide the 35 by the 7,
5.
what do you notice about this parentheses? No, wait. I'm saying, as you look at what ended up in this parentheses, what do you notice?
It's the same.
It's the same thing as the first one, and they're supposed to match in this. With the way these factor out, it's designed that that's the way it's supposed to end up. Because what we're looking for in here, and this is what's ultimately going to land in these two parentheses at the bottom, which I'm going to move up now because I thought it was good. And I thought I was going to need more space, and it turns out I don't. So here's what happens. What goes in these parentheses, the idea is you're trying to find a pair of two-term expressions that when you multiply them together by the FOIL method, or remember, I think we were even talking about last night. Remember when we were doing multi-digit by multi-digit? Remember the box method that you guys were using to multiply digit to digit? You remember,
Yeah.
Remember when we were doing something like this, 23 by 56, and we did this whole thing. You did 2, 3, and did 5, 6.
Do like the lattice method?
No, right, and the last method and those type things. But right,
was it for multiplication or for division?
No, it was for multiplication. Okay, but here was the point. But the thing is that the two-term expressions that you're
multiply it normally like that.
Right. Okay. All right. But follow my point though. The idea is that in these two final parentheses are two-term expressions. Okay. There's going to be an addition of two or subtraction of two things in here, and an addition of or subtraction of two things in here. And the notion is that when they are multiplied together by foiling or by using a box method like this or whatever it is that you want, the idea is it would remultiply and give you these four things that we started with at the top of the board right here. Now, as far as what goes in those parentheses, here's what ends up happening. And here I'm just going to reemphasize that's where we got the 7 from. Okay, so in the one parentheses, and it doesn't matter which one you put it in, okay, what statement do we have in parentheses already right now? F minus 5. So that's going to go in one of the parentheses. Doesn't matter which one. Doesn't matter if you put in the first one or the second one. That doesn't make a difference. Now, in the other parentheses, in the other one, Brianna, what do we have left on this line that is not already in a parentheses? You should see two other things. The 9, well, wait, not just the 9. The 9F plus the 7. And that's the other sentence. You make a sentence out of the two GCFs, and they make one statement, and then your common leftovers make up the other. This is what is known as factoring by grouping, okay? And I'll admit, this is an algebraic concept that nails a lot of people. And I could see why to certain extents. But if you know how to come up with GCFs, especially monomial terms and stuff like that, you at least got half the battle at that point. And just recognizing that these have to match along the way. So I hope, Paul, that helps you or whatever. I'll make sure you see this later in whatever shape or capacity. So we'll see there. All right. So I just want to make sure want to get one of those out of the way because I know my friend wanted to see it. So Jethro, your turn. To throw out what your subject is and stuff like that, so we can.
Dang it! It's in.
Oh, stop that. Okay.
No.
Whatever it is you want to throw out there, Jethro, let me know. We'll get your topic in so we can see it, because just gotta let me know what it is you're looking at so that I can come up with a suitable example. Oh, you did? Okay. Oh, okay. You sent it to my school email. That's why. Okay. I was gonna say, yeah, because no, I've got my phone by me so that if I get a Gmail, if I get from that Gmail, my personal one, I can see it there. Okay, let's see. Well, where is your?
Look, it's YouTube and
You sure? Here. No, wait.
You're on the G Suite.
No, that's.
It says G Suite right there.
That's Okay, wait. Hang on one sec. Okay.
We don't see it.
Okay, wait. Hang on. Hold on. I'm looking. But okay, it probably didn't pop up there. Yeah, You sure you sent it?
Are you sure you pressed send?
Yeah, I'm looking at both my emails, Jethro, and I'm not seeing it at the moment.
Are
there.
you sure you pressed send?
Here, wait. Just type it in here.
Just say it in the live chat.
Here, type it in the live chat. Just tell me what the topic is. Okay, that'll make it easier. We'll just make life easy.
Yeah.
Wait. Tell me. Wait,
no,
just put it
here.
Put it there.
It's way more simpler than having to email. Cause the live chat is
Yeah, just type
right here.
Yeah, just type what the name of the topic is, and we'll see it there. So we got that.
Right triangles and trigonometry.
Okay, well, what's the specific topic? Because I know that's the category in ALEKS that you're doing or whatever. But yeah, just for the record, for those out there, because I think I mentioned this the name once before here. For those who are not familiar with what I'm talking about when I say ALEKS, and that's spelled ALEKS. Okay,
not like this.
That's what it's. Yeah, not like that. No.
No.
What this is, and this is something that where I work in Belleville, where my one student in the chat room is from or whatever. What it basically is, it's I don't want to necessarily call it an enrichment software, but the trigonometric ratio defines an angle measure in a right triangle. Okay, all right. So, okay, give me okay. If you give me a second, all right, here I'm gonna load up on my end because I just want to see like an example of what type of question they're presenting in front of you, because I don't want to throw you astray here. All right, basically what it amounts to, folks, what ALEKS is, I don't want to necessarily specifically call it an enrichment software, but what my school has used it for, and a number of other schools and systems that use it for, is it's sort of like we've used it as like a complement to our traditional curriculum, and we use it as we use it. Well, obviously we know what that for, but I'm just explaining what it is. But the idea is that we use it as an enhancement to our traditional curriculum. Like I'm using it for geometry this year because that's what the majority of my classes are this year. But the idea is that it helps keep track of like your overall knowledge of an entire course curriculum and subject or whatever, because it'll give you an initial diagnostic test. And then from that test, what it'll then do is it'll tailor lessons specific to you in order to expand your knowledge in different categories and stuff. So it, to be able to try to to help grow your knowledge more and more. And periodically, as you complete topics, as it gives you examples of different things, what it'll ultimately eventually do is it'll keep on retesting you on those things that you've previously done lessons on or whatever, just to see, are you retaining the knowledge in them? Because then if you are, it'll consider you as mastered those subjects, and then it'll determine the next things then in each individual category that you need. So like, for instance, right triangles and trigonometry is one of the categories that in the geometry pie that my one student is going through right now. And what he's seeing are questions such as this one. Okay, Brianna, I need the board.
Oh, okay, it's what you said.
Something like that, yes. Yeah, pretty much.
They're giving him the test. And he's giving him the test. And then that's his lesson. And then that's the lesson thing. And then he mastered it. And then they're all happy.
Okay. I hope that made sense or whatever. Okay, so I've enjoyed that. Okay, all right, because now I got to set this up. Okay, so here's an example of the kind of question he's looking at. The subject he's talking about is, okay, using a trigonometric ratio to find the angle measure in a right triangle. The example I'm just looking up an example here. So here's the idea of what it's talking about. Okay, so he's seeing a question that looks something like this. I understand it's not the exact one that you're looking at the moment, but I'll do a couple different ones here so you can find the one that best fits the information that's in front of you, Jethro. So here's the nature, Brianna. Take a look at this. Okay, I gotta talk with mommy about that. I don't know specifically what it looks like. Anyway, so here's the story. So all right, so take a look at this. All right, so you see the right triangle, and you see I've labeled 2 out of the 3 sides here. Okay, with me so far? Now, you notice I've also marked one of the angles with X degrees. Okay, our job is to find what the measurement of that angle is supposed to be. Now, here's the way it happens. Okay, the first thing we want to establish is this. Okay, this 7 that's here. Okay, everybody everybody that majorly knows about right triangles is familiar with this one side of the triangle. That represents that one is the longest side in the right triangle because it's opposite from where the right angle, the biggest angle in the triangle is. And there's a name that's always given to this one. It's called the hypotenuse. Okay, you'll get familiar with that one as we go along time. All right, stay with me before you start getting artsy ideas here. Okay, there you go.
Hippo? Hippo.
Where does she go with
it
these
says
things?
hippo right there.
That's hypo.
Something like that. Something like hippo.
Oh, jeez. Okay, all right.
Hippo.
All right.
It looks more like a pig, but it's a hippo, I swear.
Fine enough. Okay, all right. Now, take a look at where the 6 is, Brian.
I don't know why it's supposed to be an I, but it doesn't matter.
Stay with me. Now, take a look where the 6 is, Brian. Okay, is the 6 is the segment of the triangle where the 6 is connected? Is this directly connected to where the X is or not?
Yeah.
No. See, no. Okay, but this X is connected to this line and to this line. It's not directly connected to this line. You get what I'm saying? You understand the problem? So this angle X here is made up of this side over here and this side at the bottom. Those are the 2 that it's attached to. Notice that this one is still missing. So this is not directly attached to this. This line does not make up a piece of angle X. You understand that now?
Huh.
Okay. So as a result, this one we refer to as the opposite side, which I'll label OPP. Okay. And then this one at the bottom that is directly attached to the X, we're going to call the adjacent, which we'll label ADJ. Now, the whole idea of what Jethro is going through is that depending on which 2 of these 3 sides you have labeled, there are trigonometric ratios that are used in order to be able to come up with these with any missing measurements within the right triangle. They are known as sine, abbreviated SIN, cosine, which is abbreviated COS, and tangent, which is abbreviated TAN. Okay, and how you get each of these for where that X degrees is located depends on which 2 of the 3 sides you have given to you. And there's a classic abbreviation that is used to symbolize all that. Okay. The abbreviation that you'll see when you get to the high school ranks is what is known as SOHCAHTOA.
What?
Okay. Here's what it represents. Each of these 3-letter blocks within that gibberish word. Okay.
Block.
Yeah.
Block.
Right.
Block.
What they stand for, each one of these represents the name of the trigonometric ratio that you're looking at. Wait, stop. Don't do that.
Lego block.
No, stop. Sine, cosine, and tangent, S, C, and T. And what these represent is which 2 of these 3 sides are required to be placed into the fraction. So for instance, for sine, you need O and H. O representing opposite and H representing hypotenuse. Okay. For cosine, C for cosine, A for adjacent, H for hypotenuse. So that's the adjacent over hypotenuse. That's the fraction you can make there. And TOA, T for tangent, and again, O for opposite, and A for adjacent. So in this particular question, for instance, Brianna, in this particular question, take a look at where the 6 and the 7 are located. Which two of the three were we given? Between the opposite, the adjacent, and the hypotenuse. Which two of the three were we given? Yeah, we were given the sine set because the 6 is in the opposite position. So we have sine x equals 6, which is in the opposite position, and 7, which is in the hypotenuse. So this is the
truly word block.
So, okay, fine.
They're Legos.
I got it. Okay,
Lego
so this
block.
is the setup that we have right now.
Block.
Okay, now here's the deal. To get the measurement of x, now this I'll tell you now when you get to that point when you get to high school. This is definitely calculator dependent. I'm going to show you why. Okay.
Why can't you just do it on my paper?
No. Wait.
I don't know what I'm supposed to be writing, but
stop.
I'm just
Okay, chill.
doing a bunch of dots.
Here's the problem. Because calculating sines, cosines, and tangents, there is no like direct number operation that tells you how it's supposed to go, and I couldn't even begin to try to guess what the real life formulas that cause these to be made and stuff like that, because these.
So that's why there are calculators for the older kids on the NJ Slam.
Well, okay, well.
Whenever I think of the NJ Slam, but I always think of just basketball.
Okay. Okay, but here's the deal.
I don't know.
This is then to get x, Brianna. This is what you would have to enter into a calculator in order to come up with that angle measure, because it's saying that the sine measurement of some angle is equal to the fraction of 6/7. To get back to the angle measure, you have to eliminate the sine. To eliminate the sine, you need this. You need the -1 function of that particular item. So that's exactly what I'm going to enter here into my calculator. I'm going to put in the sine -1, and then I'm going to put in, and I got to write this either as a fraction or as a division, doesn't matter, but I got to put it all in the parentheses here. I have to write it as 6 divided by 7 and close the parentheses, and then whatever amount it gives you, okay, round this to, what's the question want here? Let's see. It says rounds it to the nearest 1/10 of a degree. So take a look. It says 58.99. So how would this to one decimal place, Brianna? How would this round? Would it be 58.9 or would it be 59.0?
59.
Yeah, so it would go to 59.0 degrees, and that would be the measurement there.
Look, it's NJ Slam.
Yeah, I got it. I know what you're talking about.
I even remember.
Okay. All right, so depending on which two of the three they give you, that tells you which setup that you would have to use here. And then something similar to this would happen to come up with the angle measurement, regardless of which trig measure you have in front of you. So here, let me just try to set up one for each of the others in this circumstance, just so we could see it. I'm just trying to have it juggle where the number positions are, so you could see another a different example. Okay, at least try to come up with one that doesn't have the exact same numbers here. Aha. Okay. All right. So what about this, Brianna? Okay. Tell me which. Okay. So tell me. Okay. All right, Brianna.
I'm sorry.
Okay, Brianna.
I just remember I made a joke about that last year because, like, I remember I was drawing these things, and then I made something and I made a joke about that. Like, she brought a pillow to school and she brought the pillow to the ground and she slammed into the pillow.
I got it. Okay. So look at where So look at where I put those two measurements. Same type of problem, but this time, which of the trig measurements do I have set up this time based on everything?
16 and 7.
Okay, all right, but based on where they're located, which of the three measurements, sine, cosine, or tangent, which one is given to us this time? It is a cosine step because the seven is adjacent to the x, it's connected to it, and the 16 is in the hypotenuse. So now we've got this step. So you've got cos x equals 7 over 16. Now again, just like the last one, to get to the x, we have to invert the cosine with a cos -1, and we put the fraction in, and we see what we get. So that's what that one has to look like here. So I'm going to just type that into the calculator and get that in place. Okay, and it's showing me 64.05. So would that be 64.0 or 64.1? Which way would that round?
1.
Right, the 5 would cause the bump up to 1. So 64.1 degrees would be the measure of x in that one. And then to extend further, okay. So, all right, okay. Let me take a look here. I'll see if let me see if it came through. Oh wait, hold on a second. There it is. Okay, here, take a look, Jethro. The one we just did, if you look, okay, in Jethro's example, he's got a cosine set up here too, because take a look. For where the x is, look at the picture. He's got an 8 at the bottom right here, connected to the x, which makes it adjacent, and he's got a 15 here in the hypotenuse position, so that's a cosine setup.
The hypotenuse.
So everything we just did in that example is presented right here in this one. Okay, so this is what you'd have to punch in, Jethro, then, and put that in and see how it comes out. And let's see if you get the same thing as I'm looking at here on my piece. Okay. So take a look at that. Okay. Just a record, as you look at this one, would the decimal round up or down? It is gonna round up. Okay. If you see it, Jethro, just confirm that you've got the same result that I do or whatever. Okay. Officially, what would it round to? How would it end up reading?
8.
Well, give me the full answer.
57.8.
57.8 degrees when that rounds off or whatever. Okay, and hopefully, Jethro, you got the same thing in your answer. Okay, and then one for the tangent. Brianna, would be if they didn't give you the hypotenuse at all, and if they instead gave you, let's say, this and this, something like that. Because now the 10 is in the opposite position, the 8 is in the adjacent, so that would give you this one.
Tangent.
Yeah,
tangerine.
So that would be the.
Wait, was it tangent or tangerine?
Tangents. So it'd be tan x equals 10 over 8, and then that's where you would have to. That's where you'd have to reverse and see what that comes out to. Let's just for fun see how it plays out. 10 divided by 8, and would this round up or down?
Down.
What would it say? Yeah. Okay, well, give me the whole answer.
51.
No. If it rounds down, then keep the decimal, keep the digit that's there. So 51.3 degrees in a case like that. Okay, so. and island fruit everywhere have now been made happy. So be that as it may. So that's the story there. Okay, so I hope that one I hope that makes sense, and they were able to get the answer you're supposed to out of that business. Okay. Yes. What?
That's the thing.
Oh, shit.
What are you excited about?
Yeah, I gotcha. Yes, I hope I'm not keeping you.
No, I'm just saying. That's what I'm so
I
excited
know. This
for.
I got it there.
I'm
So,
trying to be mean.
okay. No, I know you're not. Stop. I'm teasing you. Okay. All right.
I'm
But,
trying to be mean.
all right. So I just said relax. It's okay. All right. That's good there. All right. Okay. Yeah. Stick around, Jethro. So if something else pops up along the way, you could shoot it up there, because believe me, I could definitely use more suggestions here. So
We need anything.
yes. So feel free. Whatever the next topic is, just throw out the title, and we'll take a look at it and stuff like that. Let me see. I'm trying to see if oh, okay. I'm just looking. I'm trying to look in my discrete math stuff. I'm trying to look for something else that would be easy to explain in within our within the confines of these, because I know some of these I need a little more time to be able to explain. Okay. You remember in the very first.
More voting.
Okay. You remember in the very first.
Yay.
You remember
more voting.
Okay. If you remember in the very first one that we did when we talked about voting, you remember how we did the thing with border count, right? Remember where we said like where like if there's 4 things that you have to rank, then
a person can win by a fourth vote.
Wait. Every first place vote on a ballot gets 4 points. Every second place vote gets 3 points. Remember how we did that kind of thing, or whatever? There's other voting methods that you will see that you could also that could determine the winner of an election of
a person of
a ranked election in different ways.
There's this one person who got like a lot of first votes, but that one person still won with their fourth vote.
Well, you're going to see that there is no perfect way in which to try to get the winner of election. No totally foolproof. So there's going to be obviously some circumstances where there could be some controversy in terms of the winner. Each one has its own fairness and stuff like that. Okay, all right, like here. Let me give you an example of one here. I'm going to borrow from my old book here because I just want to get the numbers in front of us here. So follow.
Orange Man won the vote.
Okay, so all right.
Kind of mad.
Okay, wait. All right, so hold on. Okay, so follow this. Okay, so here's the thing. All right, so we have a vote. So we have a matchup between 3. So we have a matchup between 4 people. Okay, and these are how the ballots came out. Okay.
So tropical fruit man.
Okay, all right. All right, just shoot me an example, Jethro. I'll come back to that after I show one of these. Okay. Okay. So there's 4 candidates, Brianna. A, B, C, and D.
And
so
which one can be tropical fruit man? Because the winner is gonna have to be tropical fruit man. Because tropical fruit man. Hooray!
I think we can't.
Whale man.
Make up your own political jokes. Anyway.
And then there's whale man.
All right. So here's what I want to know. So all right. So follow me on this, Brianna. And here, Jethro, you follow too, because I want you to play along with this, whoever. Okay. So here's okay. Wait. Chill. Okay.
Wait, how many people are in this?
There's 4 people in the selection because you see they've been labeled A, B, C, and D. All right, but here, play along. Finish in a minute because I want you to follow along with this. Okay. Looking at just the first place votes. Now, the numbers you see up here indicate how much in the election gave this for the order of the 4 candidates. So here's what I want you to do. First, just by first place votes alone, okay, how many first place votes did each of the 4 candidates get? Okay, so first for A, how many votes did A get? How many first place votes?
4.
Okay, well, there's 4 here, but take a look across the row. Anywhere else where A is at the top, they get those too.
8.
So it's a total of how many?
12.
12. So they got 12 first place votes. How many did B get?
8.
No. How many first place votes did B get?
1.
Just the 1 up here. Okay, how about C? C got how many?
9.
9, and D got the remaining over here. D got the remaining 5. Okay, so
and
now,
D is
if you were
Earthworm Sally.
okay, quiet. Wait a second. Now, so here's the thing. So looking just at first place vote, A wins at the moment. Now, A has right now what is referred to as plurality. Okay, that means that they've got the most number of first place votes out of anybody. That's what it means. It does not necessarily mean that they have the majority. Majority technically means that you have over 50%. Okay, which is not necessarily true right now because real quick, add up 1, 9, and 5, and that gives you how much? 1, 9, and 5. No, wait. 1, 9, okay, well, it's 27 total. If you add up just the 1, 9, and 5, that gives you 15. 15 beats 12. So while A has plurality, he does not have majority.
C, Sammy the Strawberry, and D, Earthworm Sally.
I got it. Okay, all right. Now, here's the thing. So here's the thing. Sometimes, follow this. Sometimes in an election can be decided just by plurality, just like this. And in that case, A is the winner. Sometimes not. What they'll do is they'll eliminate the candidate with the least number of first place votes, and then they'll recount. So right now, who would get eliminated? Okay, B would get eliminated because they're out. So here's what happens. So follow this now, Brianna. Brianna, follow this. So if we take then all the B's out, if B is eliminated from the election, now who gets this 1 vote? Who gets this 1 vote? Follow the column. Who's next in line under B?
Tropical Fruit Man.
A. A would get it. So now, that means now instead of 12, A now has how many first place votes? Now, here's 13. Add up C's and D's. How many they got? 14. 14 beats 13. So A does not have majority yet. So in an elimination so in an elimination contest, he hasn't won yet because he doesn't have the majority. So again, we knock out whoever's got the least number of first place votes. So D is out. So we take out all the D's. So in a plurality elimination contest, who ultimately ended up with the majority and wins? C wins.
He's gonna make everyone eat healthy. He's gonna make sure that people eat healthy and then fruit.
It sometimes also carries the nickname of instant runoff.
I don't think having Sammy.
Because the idea is that when nobody has the majority, like said, you run off the person who's doing the worst, and then you recalculate with or whatever the case is. So, all right. So let me see what the other topic was. Okay, solving a right triangle. Okay, so we're continuing in that category of okay, solving a right triangle. I just need to see an example in front of me.
Oh God, what did I do?
What hath Sammy wrought? Exactly.
he's excited.
Oh, okay. See, with the right triangle here. So here's like an example that I have in front of me here. Okay, so here's an angle. Here's a 47 degrees. Okay, here is a 29 right there, for example. Okay, and it wants us to come up with both of the remaining 2 sides of the triangle here, which I'm going to label as X and Y. Okay, so remembering the SOHCAHTOA that we saw a minute ago. Okay, a few minutes ago. Okay, so let's just recap. All right. So first let's solve for X. okay, I have to use the 29. So looking where the 47 is, with the x and the 29, would that be a sine, cosine, or tangent setup? Well, let's see, what is the x in the opposite or adjacent position to the 47? It's the opposite, okay? So it can't be cosine because there's no O there. And the 29 is, yeah, right, that's the hypotenuse, so that's the long one. Okay, so OH, where's OH? Sine, cosine, or tangent? OH, where's OH? Where you see OH?
That one, the first block.
Sine, okay. So this is a sine prime. Okay, so here's what you have. So you have sine of, now this time we have an angle, sine 47 equals, now you have to put the opposite over the adjacent, which means this goes on top. So you have x over 29. Okay, now this is another one that's going to be calculator dependent. So here's what happens now for this one. Okay, what happens here is to solve for x. Now, again, what operations does fraction stand for? We talked about before in the past. Fraction represents what operation?
Multiplication.
No.
Wait, not multiplication.
Wait. So wait. So wait. When you see, for instance, the fraction 10 over 5, it's division. Yeah. Okay.
Oh.
So here's the thing. So if x is being divided by 29, then to solve for x, how do you get rid of a division? What's the reverse? Okay, so what I'm going to do is I'm going to take this 29, I'm going to multiply it over to the other side, and this is now what I'm going to calculate. And that's going to mean that, All right, go ahead. I'll pick it up from here. All right, so that means then 29 times sine of 47, that means that x is going to come out to, rounding to the nearest tenth, it comes out to, in this case, a measure of about 21.2. So that's in the cosine. So you're going to have a similar setup here. This time it's cosine 47. I'm just trying to see if my student's email came through legitimately or not. Okay, now it's saying it. I'm getting delays here on my email updating. It's my school email, not the one, not my personal one up here where I'm saying to send topics here. So, but that's okay. So I'm just trying to just get it in front of me again so I could see the question properly. So, yep, okay. So it's doing the same thing here. Now, what you're going to notice in a couple of these, and I'll use the example that my student has in front of us. Like now, in this example, okay, these are actually very easy from an algebraic standpoint to solve, and the reason why I say that they're easy is because the x or the variable, whichever, ended up at the top of the fraction in both of these trig equation steps. But folks, the problem here is that sometimes it might end up on the bottom, and when it does, you have to use a little bit of trickery to try to get around those circumstances. I'll show you what I mean. And here I'll keep our labels here. That. Okay, I'll put that back in a second, just so you can see what's happening here. Because like this is the problem in ALEKS that my student is looking at here. At least if I'm reading his, yep, I am. I'm reading the screen correctly. Okay, it's showing a 50-degree angle right there. Okay. In the opposite position from it, it's showing a 15, and then it has his A and his C over here and over here. So once again, to solve for each of these individually, okay, we take a look one at a time at each of the positions where they are in relation to the 15. So first, if I use the 15 with the A, I have the opposite and the adjacent. So opposite and adjacent, that's OA, that's a tangent set. So the equation right now looks like this. It looks like tan, and then you got your angle degree of 50, equals, and then now opposite has to go over adjacent. So that means the 15 has to go on top. The A has to go on the bottom. okay? Likewise, to solve for C, here you get the 15 again, the opposite position. C is in the hypotenuse. OH, that means you got so. So that would be a sine setup to get that one. So it'd be sine 50 equals 15 over C. So here's the problem. In both of these cases, the variable's on the bottom. Now, my students have done these. Matter of fact, right before we went on distance learning, we were doing these exact kind of problems in our trig worksheets. This is like literally one of the last things that we were doing. So here's the issue of how we get around this, because we can't just multiply the 15s over to the other side because it's on the top of the fraction, not the bottom. It wouldn't accomplish anything. So the only multiplication we could do is with the variables at the bottom, and watch what happens, because there's going to be a little bit of algebraic switcheroo that happens here. If I multiply the A over to the other side, and do likewise with the C here, they're gone and they come in front. So here's a C, here's the A. So now you've got A times tan 50, you've got C times tan 50. But algebraically, if you're trying to solve for a variable, that means the variable's got to be completely single. There could be nothing multiplied to it. So to get rid of these now brand new multiplications that you've got to do a division to get rid of them. So in both cases, we divide the tan 50 and the sine 50 to the other side. And as a result, when we do that, tan 50 goes underneath the 15 here. Sine 50 goes under the 15 on this one. And notice what happened compared to the original sentence. So I'm just going to write the before and the after for this one here. So for instance, on the A equation, it started as tan 50 equals 15 over A. By the time we did this multiplication and division trickery, these switched places, and it now reads like this. A equals 15 over tan 50. It now reads like that instead. By the same token, the same thing happened down here. This one started as sine 50 equals 15 over C, but after the multiplication and the division, those swapped places, and now it says C equals 15 over sine 50. So that's what they both say now. So these are what you're going to calculate, what you're going to put into the calculator to try to get your proper answers here and stuff. Okay, so just so we can get it in place there, I will pop that in. So we got 15 divided by, first to solve for A, 15 divided by tan 50, and we get a measurement rounded to one place of about, so A equals about 12.6, it looks like. Okay, and then for C, now we just change the tan to sine, and this one rounded to one place gives us a hypotenuse of rounded to one place of about 19.6. And you should expect this one to be the biggest answer of all because it's in the hypotenuse position. The hypotenuse in a right triangle is supposed to be the largest side in the figure to begin with. So that's the principle there. Okay, so all of that is in position. I hope that all makes sense. And actually, it was good that we got that one in there too. So thank you, Jethro, on that, because actually within using trigonometry to solve for missing components of a right triangle, we pretty much went through all three possible case scenarios in these problems. We've solved for the angle measurement itself, given the measurements of two of the three sides, and we solved for a missing side given one of the sides and an angle measure, and we solved for in both possible versions when the missing measurement is the top half of the ratio or the bottom half of the ratio. So we covered all bases there. So hopefully that helps any of you out there that need any trig help get a little bit more of a better idea as to what you're supposed to do in each of the setups. Okay, so hang on to this live stream if you need any future trig help. So So that's it there, and somebody's getting antsy here.
I'm getting excited.
Okay, wait. Who is it again that you're waiting for?
Jaden.
Who is Jaden?
Jaden Animation.
Jaden Animations, and what do they do?
Well,
they do animations, obviously.
Yes.
But I mean, anything specific or?
That's the thing I'm waiting for.
That's not the way that you draw, right?
No.
Because I'm trying to think.
Kinda, I guess.
Well, I'm trying to think because some of your artwork, or whatever, like real quick, because some of you in the previous live streams have seen some of her of the which we gotta catch up on the pictures. You know,
Okay. No.
We gotta catch up on the pictures for the live streams that we've done recently or whatever, because for those of you that haven't looked at the thumbnails that we've had as the title cards on these on most of our live streams that we've been doing for this past few weeks, she's been the one drawing those. That's all her artwork. But just in case you haven't seen it before, real quick, grab the one that's on your wall, in your room. Get the one you've got taped on your wall in your room real fast. It'll show up. Oh wait, show that one. Show that first, okay? Because I don't think we're gonna have any more topics, so we're kind of out of time here. So I want to just showcase your work or whatever before we get out of here. Because if this is your first time with this and you haven't seen these before or whatever, I want to just give you guys a chance to see her work again and stuff like that.
I'm bringing up this because I feel like it.
Why?
I don't know.
No, where's the one that's on your wall? You got it taped next to your bed.
I don't want to show that one. I want to show this one.
Well, I liked it. It was nice and big too. So.
It's something.
Okay, who can I? What can I show?
I could bring up another one if you like.
Wow! Oh wow! I really like this one. A kiwi meets kiwi, I guess.
Yes.
Look at this. How do you like this one, folks? That is very excellent. No, I have not seen this one until right now. No, that's very excellent. I like that one a lot. If you like it, show your love and give this video a thumbs up just for that alone. And then you have and who is this?
A character.
Okay. Does she have a name?
Tiki.
Huh?
Yes, her name is Tiki.
Tiki.
Yes.
And what's her hook?
Like, since like I know I've like just like recolored her a lot, so I just made it like her power. She can change like her color and like the whatever pattern she has.
She's
Colors.
chameleon. She's a chameleon, basically.
Yes, and she has a sister, but I didn't put it in here yet.
Okay, well, to be continued. Continue for further adventures of Tiki.
Yes.
Maybe she'll pop up in our title card thumbnails. Maybe, who knows?
And but I was working on this.
Well, here, wait. Save that stuff for later on. All right. Okay. For right now, though, so we'll leave you on that cliffhanger. Dun-dun. Okay. And in that case, we got to get out of here or whatever. Okay. We did a lot of higher end math stuff today, but like I said, we do everything in the K-12 curriculum for this. So anybody that's got any questions, you know where to reach me. Send me at brian.sapinski@gmail.com and come to.
I should have done Sutart.
Maybe next time. We'll find out. Okay. But anyway, that's it for now. We're gonna be back on because of Good Friday this week. We're gonna be back for the next live stream on Thursday at this time at 2 p.m. Eastern time. So we hope you'll join us. Please tell your friends, hit that subscribe button. Brianna, on behalf of the whole thing, figure out what this thing is. See you soon, guys.
Bye.
England. There.